price is going to be lower, right? In equilibrium, and if everybody makes less, the price will be higher, right? But you can't control how much everybody makes. You know how much you're going to make. So, right? So maybe you bring more quality, trying to increase the price, but everybody else brings like a ton, right? And the price is still low, right? And you only brought a small quantity. Okay? And then you're stuck with the low quantity and the low price, which is bad for you. Okay, so you try to see how much everybody else is going to bring, and then also how much quantity you bring has an effect on the price, and you internalize that, right? You perceive that. You realize that you're affecting the price, but you also realize that how much everybody else brings affects the price, and maybe they affect the price even more than you. Okay. Remember COVID? Destroyed us.
Amazing.
It was great, right? It was horrible. And basically during COVID, something happened. Many things happened. But one thing that happened was that everybody stayed at home. And because everybody stayed, because they were afraid of COVID, or because they were forced, even if they weren't afraid, sometimes they were like forced to stay at home. And if everybody stayed at home, then there were no airplanes, there were no cars on the streets and stuff like that. And what happened?
You mean price went up?
What?
Price went up?
Prices went down.
Not inflation.
Prices went up later.
Yeah, but they went.
Yeah.
Well, at the beginning,
There was.
We have no demand.
well, prices of some things went up also because there was no supply. Also supplies.
That was the main problem actually, the lack of supply of certain elements, but for others, they went down.
For some things it went down, for some things it went up.
I remember flights went down. Of course.
Prices, there was zero. No,
Right after COVID.
right when the prices were
They were free.
I never opened it. I remember I went to the States, it was so cheap. I never opened.
Okay, but and in particular, one price went down a lot. The price of gas,
Yeah, oil. It went negative.
right? The price of oil went negative.
It went to -40, something like that. I think.
It went negative. Right? The price of oil went negative, which is like a little bit crazy. Okay? And why did the price of oil go negative?
Hmm?
Why did the price of oil go negative?
Because first there was very little usage for it because there were no flights, people could not drive, and many usages were unavailable, and also because you cannot just have oil in your house normally. You need certain storage, certain cost for having it. So the problem was that people preferred to just get rid of the oil because they couldn't use it and it would cost them money to have it, rather than just have it.
Okay, that's based on the real markets, not on the financial markets. That's actually an explanation of what happened. The price of oil went negative because nobody wanted to use the oil, so nobody wanted oil today. People wanted oil in the future because they were like, okay, a lot of people wanted to speculate that the price of oil would go up because obviously the price of oil is not going to be zero or negative forever, right? So if the price of oil goes down a lot, you could make a lot of money if you get the oil in the future, right? So in futures markets, right? By futures markets, if everybody wants to make the same bet, in the end, they have to close, right? And there has to be someone on the other side. But someone on the other side, if nobody wants to make the other bet, actually has to be someone who's willing to sell you the oil, right? For negative numbers. Okay, but oil also has a storage cost, right? So if you want someone to hold the oil for you, right? So you can speculate on the price of oil going up, you have to pay the cost, right? And that's why holding oil now, in order to make that gain, because you expect the price of oil to go up, costs you money. You have to pay them to store the oil, basically. and nobody's willing to buy the oil to use now. Okay? So that's why the price was negative. But that's not even what I want to get to. Because the price was negative, the oil producing countries got together. And they were like, okay, there's too much oil in the country. Right? Not in the country, in the world, in the market. And we need to reduce production, to kind of like restore some positive price. And when they did that, this is kind of like saying, well, the oil producing countries play like an oligopoly game, right? A no game, in which they're trying to see how much quantity each is going to bring into the market. They have an expectation for what's the price going to be, given how much they bring to the market and how much everybody else brings to the market, right? And sometimes they try to form like a cartel to coordinate on this. But before they coordinate, they say, well, each producer is trying to see how much they bring to the market, right? But of course, you could try to reduce your quantity to increase the price. But that's, if you're the only one that reduces the quantity, it's like you're increasing the price for everybody else, for all the other producers, which is good for them, but they get to produce a higher quantity and you don't, right? So everybody has an incentive to not do this. They're like, okay, they're winning, we're losing, because we're trying to increase the price by ourselves. Unless we all get together and increase the price, by everybody reducing their quantity by 20%, which is what they said back then, during COVID, they were like, everybody's going to reduce the quantity by 20%, so that the price goes up for all of us, and we all get the sacrifice of the quantity in a fair way. Okay, you see what kind of game was being played? But one country decided that they didn't want to participate in this, and they were kind of like screwing up the whole negotiation. And that country was Mexico. Why did Mexico decide they didn't want to participate in this?
Maybe because they wanted to free ride on the results of the negotiation.
Maybe, but everybody would like to free ride on the results of the negotiation. And so why is Mexico special? So you're Mexican. And Mexico is special for many.
Why are you special?
But why are they special in this game?
Tell us, doctor.
No, I sincerely don't.
Mexico was special because Mexico had insured the price of their oil using put options. Insured a price of like, I think 47. Also, I don't know if you remember, I think it was something like that. Okay, so if you buy put options and you're in Mexico, right, and you plan to sell a given quantity of barrels of oil, and you buy put options for that quantity of barrels, the minimum price that you're going to receive is the strike price of those put options, right? Because that's like insurance. And then if the price goes up, you benefit, you still get the higher price, but you insure the minimum price, right? Because the put options graph, payoff price, looks like this, right? Okay, so if you have those put options, if you bought those put options, then the price crashes, everybody else, all the other producers are like desperate now, and they want to get together and reduce the quantity, which was, and you're in Mexico, you're like, okay, they asked me to reduce my profits by 20%, because they want to push back the price up to a point that I've already paid a premium for the options to insure. So why do I have to pay twice? No, it's unfair. Because Mexico spent billions of dollars buying these options to self-insure it in case of an emergency, in case of something like this would happen. Precisely in case something like this would happen. And another like another OPEC plus, also together and also with like Mexico, you also have to reduce your production 20% to help bring the price back up. But up to a point where like you're like, I had foresight, I already paid the price, through the price, my price, actually. So that's not being a threat, it's just being like, look, it's not fair because you guys didn't pay billions of dollars for good options to ensure the price of 47. You see what I mean? So Mexico held out this thing and moved on. So the important thing is to kind of connect these kind of games that like producers sometimes. First of all, it's an example of like competition, right? Competition in quantities. What does it mean? It means you're in a situation where like it's not like they're like posting prices of oil and like different qualities of oil and one is like I'm gonna sell my oil for 58 and the other one's like I'm gonna give you a discount, it's gonna be like 54. In general, as a first approximation, the market is everybody brings an amount of barrels of oil into the market, into the world supply, and there is a price depending on how much they bring, right? And the demand, and the level of demand. Okay, the demand could shift over time, right? The peak will go up or down, and so on. And let's say this P of Q is equal to A minus B times Q. Okay, and like the A and the B could be like fluctuating over time. Like in COVID, the A would go down like crazy, right? And then the price would be zero at the amount of oil that's supplied in the market. Okay. And then what's going to happen in this game? From I is going to take first order conditions with respect to QI, which means I'm going to consider producing more oil or less oil. Okay? And what I'm going to say I'm going to produce more oil if it doesn't increase the world price too much in Saudi Arabia, right? Good thing I know. Saudi Arabia could produce more oil in principle and they make a profit, but it will also reduce the world price. Right? Russia too, and so on. Okay, so what's the first order condition with respect to QI in this case? We had said that the profits of Fermi were the price A minus B times QI plus Q minus I times QI minus CI times QI. Okay, this is the revenue and this is the total cost. Okay, so the first order condition was made to QI, that will be basically what's the change in profits when I increase quantity by 1 unit, is what? What's the derivative of this function with respect to QI? A minus 2QI minus B minus I minus CI equals 0. Okay, and then to calculate, okay, so now we have the first order condition for each firm, right? So we have n firms, so that's n equations, and we have n unknowns, right? Y going from I over 1 to n. So we have n equations, n unknowns. Right? And a system of n equations and n unknowns has a solution. Sometimes not. Like if the hyperplanes are, I don't know, say if they in general you would think that it probably has a unique solution, right? But it could be cases where like the planes like completely overlap and you have infinite solutions, so there could be cases where the planes don't even touch and there's no solution, but like if you threw random lines, they would usually have like one solution, right? Or random hyperplanes. I mean, and this is not how it is, okay? This is not, I mean, throwing random lines, that's not an actual thing that mathematicians would do. Okay? But you get my point. So you would think that like, in general, your guess would be that it has a unique solution. And how do we calculate this solution last class? We said there was a little trick. Right? I mean, in general, you can solve these kinds of systems, but it requires maybe like actually putting numbers into them and using MATLAB or Python or Julia or Stata or something, and doing this matrix inversion numerically. But this one you can solve by hand, fairly easily, by doing the sum, right? We sum the first two equations, so we think of it in terms of the overall quantity. So we first solve for the overall quantity, right? And then we can have here, we like, this is Qi plus,
It would be like general Q minus
this is
Qi.
general Q minus Qi, right? And then once we have Q, then we can solve this for Qi. Okay, so we do the sum of these things, and then we're going to get what? The sum across n, we're summing n, these n times, right? So we're going to have, here, like sum, and then we're going to go into parentheses, right? And this is going to be n times a minus 2b times q, right? Because it's like the sum, minus 2b times the sum of qi, which is q, and minus b times the sum of q minus the sum of qi. The sum of q is just n times q, and the sum of qi is q. So it's n minus 1 times q. Minus the sum of Ci equals 0. The sum obviously from the numerical geometry. And then we solve for q. So what do we get for q? How do we solve this for q? We have to kind of put this stuff that has like a minus, so I'm going to put it on the other side, right? And sum it. So we have minus 2b times q, minus b times n minus 1 times q, 2 and n minus 1 becomes n plus 1. Okay, right? So I'm going to have q times b times n plus 1 equals n times a minus the sum the Ci, so that means that Q will not is going to equal to A times N minus the sum of Ci divided by B times N plus 1. So that's the overall quantity into that.
We can express that as total cost, the sum of the CIs.
The sum of the CIs is not total cost. Total cost would be the sum of CI times QI, not the total cost of everybody. QI. The sum of the CIs is n times the average cost, average market cost. Right? This we said it's kind of like, you can think of this as n times C bar.
Yeah, that's what we said the last time.
right, where C bar is. The average cost. Okay, and now we have to put this here, like this Q, right? And solve for QI. And that gave us QI, let's not spend time on it. It's just like replacing that here and solving for QI, gives us QI. Make sure we spend time doing it. Okay, let's do it again, like step by step, because this is, it's good to get these things into your hand. So UI goes here, right? So we're going to have, well, the first condition now is going to be like Q I A minus 2B QI minus B minus Q minus QI minus CI equals 0. Now we're going to solve for QI as a function of Q and everything else. We have minus 2B QI plus B QI. Minus 2B QI plus B QI. That's minus BQI. Okay, so A minus B QI minus B Q minus QI equals 0. I'm looking at a different way each time. Hopefully we can see this out. So QI is equal to A minus B times Q minus CI divided by this. This is what we got last time.
Yes.
And then now we have to put that Q here and kind of start.
I don't know why last time we got like QI was equal to A minus B, but it was a parenthesis of Q minus QI. I don't know why is that. Maybe.
But we got to this last time.
Yeah, like similar, but instead of B times Q, we got B times Q minus QI. I don't know why.
Because first we did the response function. First we solved this for the QI. No, first we solved for the best response function.
Yeah.
First we solved for the best response function and then we.
Yes.
But eventually we got to this.
Yeah.
Last time.
Yeah,
Yes.
we got to this, yeah.
Okay, and then we replace this Q. Goes here, right?
Exactly.
And then what do we get?
A minus CIN plus C minus I over Bn plus 1, I think.
Oh, yeah. It was an A minus.
Ajá, y luego lo reemplazamos. Ajá.
Okay, so now we have to put this Q, right? Let's just do it. Okay, so it's going to be A minus, the B is going to cancel out this B with this B. Okay, so it's going to be A times M minus the sum of CI divided by M plus 1 minus CI. Actually, I'm not going to call this the sum of CI here. I have to call it the sum of CJ from J. People, because if I call it CI, the notation is ambiguous. Because CI here is the focal firm. All of this divided by B. Okay, and now why don't we do this? Let's take this n plus 1 here, and we bring it down, and then we multiply this and this by n plus 1.
You're missing a b.
Yeah.
A minus b times q.
No, because I cancel it out with this b. There was a b here, and there was a b here.
Mhm.
Yeah.
So b. and b.
Yeah.
Okay. Okay, so now we're gonna go like here. So now what? Now let's put that n plus 1 down there. We're going to qi equals a times n plus 1 minus a times n plus the sum of Cj minus n plus 1 times Ci divided by b times n plus 1. Okay, we're almost there. And now qi is equal to a times n plus 1 minus a times n.
Okay.
It's just a. And now, the sum of Cj, we're going to divide it into two. The part that has Ci and the part that's everything else. The part that's everything else, we're going to call it C minus I.
Yeah.
Okay, and then the part that's just Ci is just Ci, right? So this is going to be n minus n times Ci, right? So the Ci is going to cancel out with the 1 from this n plus 1 times Ci. And then the part that has, the other part is C minus I, right? So as this plus C minus I minus n times Ci divided by b times n plus 1. This was the last class.
Yes.
Right. So we call this qi equal no. Dun, 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 dun. So we put that box around it in order to make it official. To elevate.
So that will be the quantity on the Granada, right?
That's the equilibrium quantity of firm I, and the Nash equilibrium. That's the strategy, the Nash equilibrium strategy for firm I in the Coulomb model. And this is the Nash equilibrium of the sum of the quantities.
Nash equilibrium of firm I.
Did you say that that's the Nash equilibrium of I? And that one? What was that one? You said like it was Nash equilibrium of
This is the sum of this. Maybe we check, we should do the sum of this and check that it's this. Right? But it will be, right? Because then you have the sum of this is n times a. The denominator is the same. The sum of this is n times a. The sum of the c minus I is going to be like n times c minus I. And the sum of this is going to be
No, but it shouldn't be NCI. It should be 1, right? Because in the sum of CJ, you said that it was C minus I times N plus N times CI, right? There, yeah. In the sum of CJ, sum of CJ is composed by N times C minus I
But this
plus.
doesn't have an n.
Huh?
But this doesn't have an n. The sum of Cj
Hmm.
is C minus I plus plus
CI.
plus
CI.
Exactly. So it's n times CJ. Ah no, it's okay. It's only the sum of the
It's
division.
not in times. Okay, so if we do this sanity check to see if the sum of these across I the same as this or not. I mean the A times N pans out, that's clear. But this part, maybe not so clear. Or is it? Maybe it's not correct.
No, no, no,
No, it's correct. At least the book has the same answer, which is
last class we got the same.
we got the same as class, the same things in the book. So this is correct as far as we know. I mean, everything indicates that that is correct. So then, okay. I mean, it's not so easy to check that this is going to be the same as this if we sum it. But it's probably true. I mean, we could check it. Let's see. Basically, we need to check that the sum of this is equal to this, right? So what's the sum of C minus I minus M times CI? The sum of C minus I from I equal 1 to N is equal to what? Minus N times Ci. Ooh.
But isn't it like the
Why don't we take one of these? Oh no, we can because this is there.
okay?
Why don't we take this and make it minus M plus 1 Ci?
To have like the total is the average.
So we could rewrite this as the sum of Cj from j equal 1 to N, right? Which is this plus Ci
Mm-hmm.
minus N plus 1 times Ci, right? So I subtracted Ci one time more, so I have N plus 1 now. And added it here, so now I completed this one.
So
With
that's
Ci, right? So now I have, this is the sum of the Cj's, which is what I have here, right? Sum of across Ci. So now if I if I add this across all firms, that's just gonna be like n times this minus the sum minus 1 to n of this. You see what I mean? Let me do that again. Okay, yes, it's gonna be the same. It's gonna be the same. I mean, it has to. But now we can see why. C minus I, what is it? It's the sum for C minus I. We defined it as, actually we didn't write it, but we said it's the sum from J different from I of C I. Right? So if I have C minus I minus n times Ci times Ci, I can complete this C minus I by doing plus Ci minus Ci. Okay? This Ci, I combine it with the C minus I and these two becomes like the sum of Cj, right? The sum of the C's from I equals 12, right? Because this one is missing the I, right? It's all of them except I. But now I add the one with I, so it becomes the sum of all of them, okay? And then this one, minus mci minus ci becomes minus m plus 1 times ci. Alright? A or nay? A. And now I want to sum, actually this is the sum from J equal 1. And I have to make the sum from J equal 1 because now I want to sum from I equal 1 to n. Right? Because I'm summing the quantities across terms. Okay? So if I sum this from I equal 1 to n, what do I get? This one's the same for the first. So that's just gonna be like n times this. Okay? This is right here. N times the sum j equal 1 to n cj. Okay? This is just a constant. So minus, if I sum this one, it's gonna be minus n plus 1 times the sum from I equal 1 to n of Ci. Okay? But then this is m times this minus m plus 1 times the same thing. So it's going to be minus the sum from I equal 1 to n of Ci, right? And that's what I have here. You see what I mean? Or not? Okay, it doesn't matter. Just check it at home. If it doesn't convince you, you can do two things. If you're extroverted, you can complain now, and I'll just do it again. Or if you're really more introverted, just do it at home. And we move on. But yes, we've checked. I've convinced myself that is correct. And I'm happy. Okay, so this is not the end, right? So we've solved for the Nash equilibrium quantities, but now we're going to know more.
Prices.
First, prices, right? What's going to be the Nash equilibrium price?
A minus B times all that, no?
A minus B.
Like the last one, the QIC one, that's the equilibrium.
No.
Okay.
No, because they are like price
Ah,
tags,
it's
right?
the times, the one for all the firms, no?
The one for the first is P of Q. So P, we know, is going to be P of Q, we know, which is A minus B times Q, we know. what's this? A minus b times q cono.
So the B cancels out.
So then,
The B cancels out, right?
So that without the B that I know here, and that's it.
Uh-huh. So it's N times N minus the sum of CI over N plus one.
it's going to be a minus b times that, so the b cancels out, what we were saying. It's a minus a times n over n plus 1 plus the sum of ci over n plus 1. And maybe we can simplify this, right? We could call this a over n plus 1. So it's going to be a plus the sum of ci over n. What else would you want to know? Now we know the quantities in the market, the price,
Revenues of the fields.
revenues, or more importantly, the profits. Okay, so what's going to be the profit? Are the profits going to be the same for all the firms?
If they have symmetric cost function, yes.
If they're symmetric, yes. If they're not, then they won't. So the profits in the Coulomb are going to be equal to
That times.
That times.
Is that times the cost?
that times that.
Oh shit.
Use your words, guys.
PC, QIC.
It's P.
B times QI.
Yeah, PC times
Uh-huh.
QIC.
P.
So
PC.
it's
Okay,
PC
PC
is
means
just
price.
that, no. PC.
Okay, it's P. C.
Uh-huh.
Times QIC.
Times QIC.
Times QIC
Minus QIC times CI.
minus CI times QIC.
Now we just replace the animals, no?
And now we just replace the stuff. But because it has QIC here and here, we might as well do PC minus CI
Yeah.
times QIC.
So it's the margin times the quantity.
The margin in dollars, the dollar margin times the quantity. Times QIC. And what's the margin in dollars? It's this minus CI. Right, so PC, just gonna be as an aside here, on this side. PC minus CI, the margin, right, is the dollar margin, or euro margin, I'm sorry. Euro here in euro. For a second, I thought I was in Wisconsin. The euro margin is equal to I'm gonna write it this way, this is gonna blow your mind. A minus CI minus A times N minus the sum of CI and now the sum of Cj. And j equal 1 to n divided by actually, this is not so big. Sorry. Not ready for it. Not yet. Not for this. And what we're going to do, we're going to take this one. We're going to do A plus the sum from from j. You see why, do you understand why I have to turn it to j? And I'm doing it for I have this sum from I equal 1 to, okay, saddle point. This is not a saddle point like in optimization, it's saddle point. Okay. This is kind of a saddle point. Notice, have you guys noticed that when I write these sums from I equal 1 to n, I only write them for the aggregate things, like the price or the aggregate quantity. Whenever I write like a sum for across all of the firms, but when I'm talking about like an equation that involves that's only for firm I, rather than not like the one for QI, I write it using J. Okay? Why do I do that?
Because your decisions depend on the other steps, in this case, cost function as well.
Well, that's a very economic kind of sounding argument. I mean, my argument is more like mathematical notation. This is just a subtle mathematical notation point. If I'm talking about a focal from I, and I'm talking about CI and QI, if I want to refer to the sum across all firms, it's confusing if I did the sum from I equal 1 to n. Okay, because that I'm kind of fixing it conceptually. You see what I mean? So I have to do the sum from j equal 1 to n. So I have to change the index for the for loop. You see what I mean?
And what is the difference then between j and minus I? Or they're the same thing, it's all the firms that are not.
No, j minus I is the sum for j different from I. That I can do. Okay, that's C minus I, or Q minus I. The minus I index refers to the sum of something from j different from usually in this notation. Okay? But notice how I'm using, I have to use j as the index. Sorry, not of Cj, as the hypothesis, exactly. You see what I mean? So I have to use the j. When I have things that are moving, the index is moving there, I can use the I index because the I index is referring now to this fixed, like focal point that I have. Okay? Okay, now let's go back to this. Okay, we'll do the margin. So we have A plus the sum from j equal 1 to n. So I have to convert it to a j of Cj divided j plus 1 minus Ci. Okay, so that's the price. That's the price minus the cost. That's the dual margin. And this, and now I'm going to bring the Ci up here, and I'm going to express it in terms of C minus I and Ci. Okay, so that's going to be A plus C minus I plus Ci minus n plus 1 and Ci over n plus 1. And now I'm going to combine these two to get A plus C minus I minus n times C over n. Okay, so that's the margin. C minus C. And the profits are the margin times the quantity of firm I.
So that's for one firm, right?
This is the margin. The margin has to be for one firm. Then I could try to do the average margin for firms, right? The margin involves the margin of the different firms is going to be different. because some groups have lower costs than others, but the price is the same for everyone. Because there's a homogeneous product. So the margins, if they have different costs, have to be different. So this is the margin for Fermat. And the profit of Fermat is the margin of Fermat times the quantity of Fermat.
So
So that's going to be A plus C minus I minus I times CI divided by n plus 1 of the margin times the quantity. And the quantity is
The same with
the same with the B.
behavior.
C minus I minus n times CI over B times n plus 1. Okay, so this is equal to 1 over B times, or maybe better, this is equal to B times A plus C minus I minus n times CI over B times n plus 1 squared. Or B times the quantity of the line squared. So the profits in Coulomb are going to be equal to B times the quantity of the form squared.
The slope is the quantity squared.
The
The slope of the price function.
is the slope of the price function times the quantity squared. Okay. Okay, so then I would say then we basically solved the Coulomb. Okay, we've got like a full characterization of the outcomes, price, quantities, and profits under the Coulomb. Questions? Okay, now let's look at the case of symmetric firms. Again. Okay, well, again, now which we didn't even consider. So, let's do symmetric firms for simplicity. We could go into asymmetric firms, but let's go to symmetric firms. So, CI. Symmetry here means that we have the same margin cost.
So, no question. Is this C minus I minus elevated to N right here?
No. C minus I minus, yeah, where you were.
Oh, no. Minus, sorry.
Okay. So we still
And how could this, how that, no, just my font size was a little bit.
That's not heterogeneous.
Yeah, why don't we like, I don't know, yeah, release exponentially to the B times,
Why don't we take logs?
maybe that can help. Could be. Okay. So, symmetric firms, CI equals C for all I. In that case, what's the profit margin? Or what's the price? What is the price? What's the magic rule? Price. We have it here, right? It's going to be A plus the sum of C of CI. So price with n firms, if we know, is going to be equal to A plus N times C divided by N plus 1. With symmetric forms. Okay, and these write N times C because it is like the sum of Ci and all the C's are the same as N times C. Okay, so I'm just taking that formula and just imposing Ci equals C for I. Okay, these I could think of as A times 1 over n plus 1 plus N C times N over n plus 1. Okay? So it's like an average, it's like a weighted average of A and C, right? So it's a weighted average of A, which is the maximum willingness to pay in this market, right? How much is the maximum, is the consumer with the maximum willingness to pay? It's like if I wanted to set the highest possible price that I could set, right? I would set the price equal to A, right? And I would set to like only one infinitesimal consumer, basically, right? So the highest possible price that I could even think of setting. And C is the marginal cost, right? So that's like the lowest possible price that you could perhaps set here, right? If you think of this as like a bargain almost, you know, the consumer side and the supply side. The supply side is never going to sell at a price below C, and the consumer side is never going to buy anything at a price above A, right? And so the price is going to be a weighted average of those two kind of like extreme points. Okay, and the higher, if we plot this as a function of m, the higher the m, the more weight you put into C, and the less weight you put in on the A, right?
So
So
that
as
is
n goes to infinity, this goes to C, this
C.
goes to 0,
This goes to 0 and that
this
goes to 1.
Right, 1 over n,
So it returns to like the price equals the marginal cost.
it converges to marginal cost.
Perfect competition.
The perfect competition. As the number of firms go to infinity, we
Which
will
makes
know
sense.
the price converges to marginal cost. In Bertrand, as the number of firms goes to infinity, the price converges to also marginal cost, but it just converges immediately once you have two firms, right? But here it's like slowly, gradually,
Oh yeah.
beautifully going from monopoly with one firm, because if you do this model with one firm, it's a monopoly, right?
Yeah.
From the monopoly price all the way to perfect
Market.
competition. So this model nests perfect competition and monopoly. So does Bertrand in a way, but just
Yeah, but Bertrand-
two.
Bertrand is only two options: monopoly or perfect competition. There is nothing else here, at least.
Right, exactly. Okay, so that's
What's A? You can say the maximum willingness to pay.
maximum willingness to pay, right? If you have a demand function, right? Remember the demand function? It's like our inverse demand function, we said that it's a willingness to pay times. Listen, I got a bad cold on Saturday,
A bad
but
call?
a bad cold, but it seems to be mostly gone. Hopefully I don't give everyone like a cold. It wasn't that bad.
cold.
A cold. Okay, so this is quantity, and this is willingness to pay, right? And that's our inverse demand function, right? This is P of Q, right? And this is A, here, right? The maximum willingness to pay of the consumers in the market, right? U. That's you.
Yep.
17 for the body.
17 for 200 grams of
No, no, no,
butter.
no. I replace it.
No, 17.
With 17 corn.
Of course, I replace
You're
it.
still there.
I mean, we know you love like garlic. It's not a bad thing. It's just you have a refined taste.
I mean, the fact that he's willing to pay that much doesn't mean he's gonna pay that much.
No.
It just means he's the one who
Just enjoy it.
values in that. He's gonna enjoy that butter like more than anyone else. So no
Exactly.
reason to
He's,
mock it.
he's the one who's gonna benefit the most from buying the butter at
And
the
everybody
price he
everybody who
sells.
buys it is gonna pay the same, but he's gonna get the most rewards
Exactly.
from that butter. You know, it's like you're gonna buy that butter. You're willing to pay €6. You're gonna be like, it's nice.
It's
But
good.
he's gonna be like crying there. That's the best possible outcome for me.
Yeah.
Okay.
Que chulo, le pongo la mantequilla cara.
Okay. So that's Kuno with symmetric firms. Now let's make the model actually more general. Let's do Kuno, but with general demand function. With general demand and cost. Kuno general demand and cost function. So now from I, that's P of Q, which is now general, times Qi minus Ci of Qi. Okay, those are the products of from I. And the first order condition with respect to Qi is P prime of Q times Qi plus P of Q minus Ci prime of Qi equal to 0. Okay? The first condition of the Coulomb with general demand and the function looks like this, where Q obviously is Qi plus Q minus I. Okay. And the second order condition is P prime of Q times Qi plus 2 times P prime of Qi minus Ci prime of Qi less than 0. It's good to know. What about the margin? The margin for now. I take this part and then we're going to move this there. Okay, so P of Q minus the margin cost of for I divided by P of Q is equal to minus P prime Q times Qi divided by P of Q. And this is equal to the profit margin, sorry, the markup is equal to minus P prime of Q times Qi.
What is it? Net? It's a negative markup? I don't think so.
No. It's not, is it negative marker? Is this positive or negative?
That's
I
negative.
mean,
It's related to elasticity, good. Is it negative?
no, because the derivative times qi is supposed to be a negative, right?
It's because this is negative.
Yeah.
Exactly. It's
Right.
negative times
Whereas
negative.
minus.
Okay.
So it's not.
So it's positive. Mhm.
So it's positive, it's related to, it's an elasticity. Which elasticity is it?
It's the band elasticity, right?
It's related to an elasticity.
But
It's
like
it's the inverse demand.
it's what you said about percentage terms, and it's a percent is the, yeah, it's like the percentage
It's in-
change in price of elasticity.
It's in percent, I mean, we can write P prime of Q, in this case, is equal to dP over dQ, right? And then we have over P, right? So dP over P, that's in percentage, that's the percent change. And then here we have to have a dQ over Q, right? And then it would be like, this would be the elasticity of price with respect to quantity, which is like the inverse elasticity.
Exactly. It's the inverse elasticity.
Okay? So there's something a little bit annoying here. Annoying. I'm a little bit annoying. But also something that's also a little bit nice. Some annoying and nice at the same time. Which is that I don't have Q, I have QI. So then there's two things I could do.
QI times N.
QI
Times N.
times N is what?
Symmetric cost function.
Assuming symmetric, but I'm doing general here. So I don't want to assume anything.
And you're going to do a plus that with Q minus I.
What do I do? Plus Q minus I. Minus
times QI plus Q minus I. No. Instead of times QI. And you get that.
No, because
That's-
then you're
that's not-
changing.
That's not going to lead me anywhere.
You should just substitute QI to, when Natalia said, you substitute QI and put it in terms of Q.
Okay, what did you say? Derive QI in terms of Q. Yeah, okay.
You substitute.
And we could try to do that. But we're going to do something simpler.
Yeah, because that sounds complex.
Because that sounds complicated. I mean, it's not a bad idea. No, we can do two things. One is to do this times Q over Q. Okay? All trick. We're learning a lot of tricks, but we're also learning good things.
And what was the good news, Jose? I said.
What's the good news, Jose Azar?
Yeah, because
It's
he
like,
said it
Jose
was
come here
wrong.
with bad news every class. I mean, so, well, the good news is that we have even more interpretation than before, actually. Because now we have the elasticity, the inverse elasticity of demand here, right? With the minus. We have the inverse elasticity of demand at the market level, right? At the market elasticity. And then here, what do we have? QI over Q is
A market quote of QI.
the market share.
The
In
market
Spanish
share,
es
the market
cuota de
power.
mercado, in English it's the market share.
The market share of
Okay.
QI.
So this is equal to 1 over the elasticity of demand times the market share of firm I, right? I'm just gonna write it as SI over, okay? So this is the market share of firm I, which is defined as QI over Q. Okay? So it was annoying because we couldn't just say it's the inverse elasticity of the market,
Because it was a QI.
but then we get this SI, which is kind of nice because now we're talking about market shares, which is something that real people talk about. Okay, so now we have an expression for the markup of firm I that's
Also
not,
includes
that also involves the market share of firm I.
Guapísimo.
Okay, so it's proportional to its market shares. Guapísimo. Beautiful. Très belle. Sorry, maybe my French is not as good as yours.
And it's logical because the markup depends positively on how much market the company has and negatively to how easy it is to that product to be exchanged by other products.
The markup depends positively on the market share of the firm. Bigger firms, in terms of the market share, have higher markups and have more market power. And firms that have more elasticity have lower markups. Okay? But wait, there's more. We said this is the market level elasticity of demand. Okay? What we had before, without doing the Q over Q trick, this is also an elasticity in itself. It's the inverse, it's a firm level inverse elasticity of demand. Because what's the firm level elasticity? It's going to be, the firm level inverse elasticity is going to be delta P with respect to QI times QI over P, which is what we had initially, right? So this is 1 over eta I, right? 1 over the firm level elasticity of demand. You see what I mean? And the only difference is that we have QI here, as we had before, instead of Q. And then here we have dP over dQi, but dP over dQi is equal to dP over dQ times dQ over dQi, but dQ over dQi is the change in the sum of the Q's with respect to QI, which is 1. Right? This is the derivative of the sum of QI with respect to QI, and the derivative of the sum, the derivative of A plus B with respect to A
Is one.
is 1. You see what I mean? So this is just the change in the price. It's like the change in the price. When one firm changes its quantity, is the same as the change in the price when quantity goes up by 1 by any firm. So it doesn't matter which firm is raising the price, it's raising the quantity. The effect on the price is the same. Right? So dP dQ is the same as dP dQi. And so this is the percent change in price with respect to the percent change in the quantity of firm I, or the inverse elasticity of demand for firm I. So this SI, another way to interpret this formula is different firms now have different elasticities at the firm level of the price with respect to their quantity, and they all set the markup, they all choose their quantity in Cournot when the markup is equal to the inverse elasticity of the firm for them. And the inverse elasticity of the firm for firm I is the market share of the firm divided by the market level elasticity. You see what I mean?
Yeah.
Okay. Should I say that again? And a way to interpret this is, so basically it's very important here to realize but there's two elasticities of demand. There's the elasticity of demand for the market as a whole, and there's the elasticity of demand for Fermi, the firm level elasticity of demand and the market level elasticity of demand. Who has a higher elasticity, the firm or the market?
The
The firm.
See, yeah, the firm. Yeah, because it's like, no, but it can have a
No,
market, because the market aggregates the elasticities of many firms, so it's just an average, that one is higher.
Depends.
The market always has a lower elasticity than the firm. The firm always has a higher elasticity than the market. Okay, remember that when we're talking about the elasticity, the intuition is if you have a monopoly, the firm, if you have a monopoly over something bigger, your elasticity is going to be lower, right? Because people can't go to other things. Here you're thinking, okay, what happens to, now let's think, we're thinking of this in terms of the inverse elasticities, but think of it as in terms of the elasticity. If one firm here raises its price, people go to the other firms in the market, right? The elasticity is more, but if the market as a whole raises the price, people go outside the market. It's not so easy. Okay? And in particular, if the firm is a monopolist, then its elasticity is the market level elasticity because its market share is equal to 1. Okay? And if the firms go to perfect competition, their elasticity goes to infinity. Their inverse elasticity goes to 0. Their market share goes to 0.
Yeah.
You see what I mean? So the inverse elasticity of the firm is the market share over the market level elasticity, right? And if the market share goes to 1, this goes to the monopoly inverse elasticity rule, right? Where the monopoly face the entire market demand for themselves. And if the number of firms goes to infinity, this goes to perfect competition where like the firms just have to set price per marginal cost. Okay? Questions? Okay, before we start with the next topic, I want to do one more thing. Yeah.
May I ask you, so you said that just to make it clear, the firm level elasticity of demand equals the market share? Because I didn't really
The firm level inverse elasticity of demand
the inverse?
equals the market share over the market level elasticity.
Really?
The firm level inverse elasticity of demand equals the market share over the market level elasticity of demand.
Okay.
And okay, I mean let's do it like here. I mean it's like you can have P prime of Q I mean why don't we use this whole board to do that math again? Because this is kind of like really important. I'm going to go over this again because I'm tired of writing referee reports explaining this to people. So I'm going to explain it to you now. Sorry, I'm just joking. But it's true. Sometimes I have to explain this in the reports. I just want you to speak. Wake you guys up a little too. This is something that happens in research. I mean, this thing of discussion. But I'm not angry. I basically kind of never get angry though. It's like if I look angry, I'm joking. Probably. Most likely. Okay, so let's see. Your question is basically, what's the firm level elasticity of demand? Firm level elasticity of demand is d Qi dP times P over Q. Okay? The market elasticity of demand is dQ over dP times P over Q.
So, you assume that price is the same for everybody. That's why in the
Yeah.
FMC there is demand.
The price is the same for
Price
everyone
is the same.
in Kuno because it's a homogeneous product. Okay, so this is the firm level elasticity, this is eta, which is defined as this, which is eta defined as this.
The first one is firm level.
Could be, claro.
Sí. And now what about the inverse elasticity? The inverse elasticity, 1 over eta is equal to dP over dQi times Qi over V. Right? Definition. And this is percent change in price with respect to percent change in quantity of Fermat, right? And the inverse elasticity of Fermat, for Fermat, is going to be change in price with respect to, oh no, sorry, this is for Fermat. This is for the market, and this is for Fermat. dP over dQi times Qi over P, right? It's percent change in price with respect to percent change in the quantity for Fermat.
But
Okay, and this here is the same as dP over dQ times Q over P times Qi over Q. Okay, and Qi over Q is equal to the market share of Fermat. Okay, and this is the inverse elasticity of the market. We have until 2:30, right?
Yeah.
I need to tell my previous student that only at 2:30 because I always sit in these classes at 1:30, but it's at 2:30. Okay, so basically this is like a nice result. It's basically like in Cournot, Fermat is going to set markup equal to the inverse elasticity of Fermat, right? But the inverse elasticity of Fermat is the inverse elasticity of the market times the market share of Fermat. Okay, this is what we have over there. But then what if we do the average markup in the whole market? The average markup is going to be the sum from I/1 to N of, in this case, the firms are heterogeneous, so I have to do a weighted average, okay? We have to be average weighted by market shares. So weighted by this, of P, of Q minus C average, of Qi prime over P of Q, and that's going to be equal to the average weighted by market shares of the inverse elasticity of the firms, right? 1 over I. because the markup of Fermi is equal to the inverse elasticity of Fermi. But the inverse elasticity of Fermi is equal to its market share over the market level elasticity. But the market level elasticity is a constant, so it can come out of the sum. And now we have the sum of SI squared. So this is equal to the sum from n equals 1 to n of the market share from I squared divided by eta, which is equal to the Herfindahl-Hirschman index of market concentration divided by eta. Okay, this is called the Herfindahl index, okay, which measures market concentration. Okay, the Herfindahl-Hirschman index measures market concentration. So the average markup in the market, if we know, is proportional to the level of market concentration in the market. It's basically a function of two things: the market level inverse elasticity and the level of concentration in the market. So if the market is more concentrated, there's going to be more
average markups.
more average market, right? More market power.
Yeah, in case
But
we
that's
have,
conditional on the elasticity of the market. You
yes.
have a very concentrated market for a very elastic product like
Water.
artisanal carbon, like a butter, and or maybe water. Water depends, but yes, artisanal garlic, like a butter, a very small kind of niche product that has like a lot of substitutes, and the markups not going to be high.
But wouldn't it be that the sum of all the shares in the market is 1?
This is the sum. Yes, it's true. The sum of all the market shares in the market
Is 1.
is 1. So that's why the index is not the sum of the market shares. It's the sum of the market shares
Square.
squared,
Okay, yeah.
which is a weighted average
Yeah.
of the market shares weighted by market shares.
Yeah, exactly. So, for example, if one firm holds, let's say, 95% of the power, it's gonna be close to 1. But if there are a million firms that pretty much all of them share 0 market power, it's gonna be really close to 0. So there is really little market concentration.
Right. I mean, nice property of this index. Suppose that there are 2 firms in the market. Right. What's the Herfindahl-Hirschman index? What's the HHI if there are 2 firms?
Depends on the market concentration each firm has.
Yeah.
Of the market power each firm has.
Okay, well, so there's 2 symmetric firms. So
No, they
question.
have 50-50.
So when you say market concentration, you mean how much a firm has of the market in terms of ownership?
yes, the market concentration is how concentrated the market shares are. The HHI measures how concentrated market shares are. There's different measures of market concentration. This is one of them. There's also like the CN
Okay.
index, the CN, basically like this CN, for example, like the C4 or C8, right? The census and touch reports is as well as the HHI. C4 is what's the market share combined of the largest 4 firms.
Okay.
Right, so like 4 firms have 80% of the market or something like that, right? Or C8 is the market share of the largest 8 firms. The HHI is nice because it summarizes the market share of all firms
Yeah.
in the market.
In this case,
So it includes all available information.
in this case, it would be 0.25, no? If it's
If you have 2 firms,
yeah, it's
symmetric,
Huh?
if you have 2 symmetric firms,
Ah, it's
the
0.5.
HHI. is 0.5, right?
0.5, yeah.
This is gonna be 0.5 squared plus 0.5 squared,
Which is 0.5.
which is 0.25 plus 0.25, which is 0.25 equal to 0.5, right? So I have two firms, it's 0.5. What if I have three firms?
With symmetric.
It's
With symmetric.
with symmetric. Okay, what if the firms weren't symmetric? If one firm has a market share close to 1,
Mhm.
It would be close to 1.
it's going to be close to 1, right? So the more concentrated these two firms are, the higher it's going to be, right? This is the lowest it can be with two firms. What if I have symmetric? This is the lowest it can be. What if I have 3 symmetric firms? It's going to be lower.
Yeah.
And what's it going to be?
You have to do 0.33 squared plus
The
0.5.
market share is 1/3, right?
Yeah, so
One
it's,
third.
Ah, so
Square.
It's 1/9.
Moving over first.
1/3 squared is
So it's
1/9.
1. So it's 1/9, 1/9, 1/9, 1/3.
Zero, tell us zero.
It's going to be 1/3,
Yeah,
right?
1/3.
It's going to be 1/3 square, sum 3 times, so it's 3. Right? So the square is going to cancel out. It's going to be 1/3, right?
So the minimum is 1
Just
over the
remember,
number
this
of
is a weighted average of market shares, weighted by market shares. But if the firms are symmetric, this is just going to be like the market share, right? So then we get 1/3, and basically, if we have n symmetric firms, it's going to be 1 over the number of firms.
And that's the minimum index we can have.
And that's the minimum HHI you can have
Okay.
with this number of firms. So it's going to be, in general, it's going to be, you can also rewrite this as a function of like the number of firms and the variance of the market shares. Right? This looks like a second moment. Also, the sum of squares of, this looks like an uncentered second moment. So you know what moments are of the distribution? So yes, you can write it also as a function of having number of firms and the variance of the market share. So basically, the more firms you have, the lower it is, the more the variance, the higher it is. And
Yep.
what else? If you have 4 firms, this is equal to 0.25. Right? The HHI. 0.25 in lawyers don't like fractions.
Of course.
And so, lawyers are like our bosses, you know, my friend, lawyers. You know, they like to express the HHI not in terms of like market shares that are fractional, but in terms of market shares between 0 and 100. And so the HHI for them is between 0 and 10,000. Yeah, because if you multiply two things that go between 0 and 100, right, some squares, it goes between 0 and 10,000. And so for lawyers, an HHI of 0.25, right, an average market share, they call it an HHI of 2,500. Okay? And that's what used to be a highly concentrated market in the guidelines, in the horizontal merger guidelines. This used to be considered a highly concentrated market. Basically, people used to think, in antitrust generally speaking, they had like rules of thumb that was basically antitrust, you know, we don't really know how the economy works very well, but more or less, it's not a good idea to let firms combine when the number of firms in the market is 4 or less. If the number of firms in the market is 4 or less, if it's a 4-to-3 merger, that could be bad. You know, people could complain. So we don't know. Maybe it's still a good merger. There's exceptions, right? But then you have to prove that it's a good merger. But generally, this is going to give some pros. And the moderately concentrated would be like the HHI corresponding to 6 symmetric firms. So if you have 4 like symmetric firms in the market, antitrust people will be like, if you want to do a merger and there's only 4 firms left and you want to combine them so So there's gonna be 3. You have to explain, hire like a nice consulting firm, pay them well, and prove that your merger is a good merger. Okay? It could still be a good merger, so you could argue a bunch of things. I mean, I'm not gonna go over the things that you could say. I mean, but in general, it's gonna, especially if the increase in the HHI from the merger is high, right? If you have like basically almost the same as 4 firms, but then you have like a little fifth firm that's very small, and you're gonna buy them, it's like maybe the HHI doesn't go up almost as much. You're not like one of these. It's not the same as if 2 of these big 4 firms merged, right? But it may be bad for other reasons. Where you could say like, okay, they're buying all the small competitors, so they're not letting entry. They're not allowing entry to the market. Let's see. I mean, you could argue in favor of like a 4-3 merger. I mean, you could say, look, there's like 2 big firms, right, that are bigger than the other 2, and the other 2 can't compete with the big 2, right? They're very because they're very weak and they don't have enough capacity. Suppose you have telecommunications, right? So you have like 4 big like cell phone providers, and like 2 of them are really big, but then there's other 2 that are kind of like struggling, and they're not as, I mean, in cell phone you need like capacity. The more network you have, the better the service is going to be. So these 2 can't really appeal to the consumers. They want to have, if you're going to buy like a cell phone and you have like a provider, you want to have like one that has a very big network, right? Or has access. How the others have to maybe pay for access to the network. It's more expensive, right? You're like, but if these 2 small ones, relatively small ones combined, then they would be able to create like a 3rd competitor in a market that has 4 firms, but really 2 dominant ones, right? So instead of going from 4 to 3, you're really going from 2 to 3 in practice, because you have 2 that really matter and 2 that don't. But if they combine, now they matter, and you can go from 4 to 3. So that's one possible argument, right? So you have to see if it's good or not. All right, let's just keep going. I mean, and we'll take a break kind of at the end. We'll just leave early. Okay. Are you guys tired? No, this has been like super fun and like, relaxing. It's cool now. This is cool now. So I think we can keep going and we leave instead of 2:30. But let me tell this student that the class is actually instead of 2:30. But I'll tell him like 2:15. All right, so that's cool now. I'm like trying to questions. Okay, so now let's see a couple of variations in this. Let's see. Why don't we do? Okay, so you have this Coulomb oligopoly, right? And let's really talk too much about like where monopoly power and market power comes from. Right? So why is there an oligopoly in the first place, right? So we look at markets and we say, okay, some markets are oligopolies, some are monopolies, maybe some are more perfect competitive. So something to think about, right? Where did this come from? So one possibility is that there's a monopoly or an oligopoly because of the government,
Right.
right? Some might argue even, like Milton Friedman and Murray Rothbard and Javier Milei, that most of monopoly power, when you see monopoly power, the first thing that should come to your mind is the government has their hand in this, because we know that markets in general tend to do a good job. If something's not working, the first suspect is
The government.
Moncloa. The government. Moncloa is a
It's Spanish.
sorry, no, Close the window here.
Moncloa is the residence of the president. It's like the White House in the United States in Spain.
The White House.
Es donde vive el presidente. Pues, ahí lo
Potential source reason for monopoly is the government gave some companies a concession over some area of the economy, right? So you say, okay, for example, there's like some spectrum, right, that you need to use for telecommunications. To participate in the telecommunications market, you need to own a piece of the spectrum, and the government auctions that to companies, and whoever buys the spectrum in the auctions gets to participate in the telecommunications market. And those who don't, I don't have any spectrum, so I cannot provide telecommunication services, right? So that's a natural, first of all, you could say, and it's also natural because you don't want a million people to have like a tiny bit of the spectrum and they can do a good job. So it's natural that somebody has to own a big chunk of spectrum, of the electromagnetic spectrum, right, to provide decent communications for the country, right? So the government's going to auction it, they're going to get some revenue from that, but then after that, we could try to design the auction as best as possible to try to get money from the private sector, but then the private sector has a monopoly or an oligopoly. Maybe there's like several companies that own like chunks of the spectrum, and that's it, right? So that's where the number of firms came from. Could also be that there is some cost of entry. Okay, so that could be like a natural oligopoly or natural monopoly market. It could also be that the product requires some patents to be produced. So somebody had to do some innovation, right? And then they patented that, and the government, through the patent system, grants whoever holds the patent a monopoly for a certain number of years, right? So again, the government is granting monopoly power to whoever has the patent, right? Could also be that there is some entry cost, right? Some cost of entry into a market. That could also be related to the government, because maybe the cost of entry, the fixed cost, is related to the regulatory burden of, for example, producing cars, right? In order to produce cars in the European Union or producing food that can be sold in the European Union, you have to pass certain regulatory thresholds, right? For the safety of your cars or the safety of the food and so on. The higher the regulations, the harder it is for like small companies to enter the market, right? But the fixed cost also maybe doesn't come from the government. Maybe it comes from the fact that you have to learn how to produce the product by yourself, and it has nothing to do with the government, right? In general, there's some fixed cost of creating a firm. Like when you create your battery company, I'm assuming that we had some fixed cost, even something as simple as a battery company. Like what do you have to do?
Machine, the blender of the water.
You have to buy a machine for the batter, right? Before you could even like have like your variable inputs. So there's like a fixed entry cost into a market. Maybe machines is not exactly a fixed cost of entry, because if you want to produce more, you have to buy more machines. But maybe you had to, I don't know, spend Sometimes learning how to make butter. Where did you learn to make butter?
With my dad, yes.
With your dad, since you were a kid?
Yeah.
Well, there's your fixed cost. Maybe you were having fun, so your dad paid the cost. Or maybe it was fun for him too. Maybe it was a negative cost. You know, father, son, make butter. Sometimes it's fun, you know. Like, I also make things with my kids, you know, we make chocolate, homemade. We make bread. We haven't made butter so far, that's really a project, you know. And for me, it's fun to make the chocolate with my kids. But there's a point when it becomes not fun. You know, it's a point where like, we make chocolate now. I don't want to make chocolate, and my kids are like, we're making chocolate. And when are we making chocolate? You know, I'm like, well, not today, but they start crying, you know. So, it's like, but in general, maybe that's not what you usually consider like a fixed cost. But in other things, you may have to pay a fixed cost. I don't know, give me an example of some industry.
The training industry is usually considered a natural monopoly.
The trade industry is considered natural monopoly. But here I'm not talking about natural monopoly. You know. The trade industry is another example of government concessions, right? It's like,
If you wanna have an airplane,
Pharmaceutical companies, they are
Pharmaceutical
like a very good
companies.
example for this, right?
okay, yeah.
So you have like, the laboratories are always a fixed cost, you need to be constantly developing their products.
Right. You have to pay this fixed cost of the laboratories developing the drugs, and only once you learn how to develop, how to make a drug, and learn that it works, if you're the first one to ever make it, then you can start producing and selling the drug, right? Okay, so there's a cost of entry. So, what happens if I want to do, like, okay, and then what if the market is like, how do I do a model with entry? And with a cost of entry?
how do you model what?
How do I write down an economic model in math that includes entry and a cost of entry?
Like, but the cost of entry is gonna be fixed, or is gonna be dependent on how many companies are there in the market? Because it could be just like a cost there in your profit function, you have minus CIQ, and then minus a cost of entry, right? But it is a function of which variable is the cost of entry. That's what I'm asking.
It's not a
It
variable.
could be a fraction of the number of companies in the market, because maybe if more people do this, it's easier to learn how to do it.
Or it could be like a function of the quantity, the more you produce, the more ¿cómo se dice amortiza? Espero. Bueno, se amortiza más.
Okay, that's a different thing. Okay, good. It would be good to write this thing out to like kind of separate these things. Okay, she's saying if there's more companies
Mhm.
in the market, you can have a lower quantity. Each company probably is going to be harder to amortize
Yeah.
this cost of entry, right? And to justify that you pay this fixed cost of entry. So, but in that case, the cost of entry could still be like a fixed cost, but you have to pay it. The question there is, can you recoup that fixed cost that you paid, or not?
Or maybe like the cost of entry is just a fraction of QI. It's just like, you know, like, no.
Okay, let's think about Kuno with free entry. I mean, suppose that the market is Kuno. It could be Kuno, or it could be something else, but like, just to illustrate how we write a model with free entry, why don't we start with writing a Kuno model with free entry? Okay, then we could write any model with this kind of like same kind of reasoning. And free entry. Okay? We could take the trend and add free entry. Kuno. Okay, so this is gonna be a two-stage game. First, there's a large number of potential entrants. There's like millions of people that are going to the market, and from this basically decide whether it's going to or not. And then, once n firms have entered, they play within firms.
So in perfect market competition with free entry.
Is it the same as perfect competition or not? We'll find out. And let's say the firms are symmetric costs, right? So how do we solve a dynamic game with two stages?
By backward induction, right?
By backward induction, okay? So we have to backward induction, which means that we need to reason backwards. Okay? Induction just means reason. How do we reason backwards? We have to say, okay, what would happen if n firms had entered? And then we play the Kuno game with n firms, and we just did that. Right? So we've solved it, and the solution is like there. Right? But that's the price. And then we can also write the profits within firms and so on, right? So second stage, we have a quantity of Cournot. And we're gonna call it quantity of Cournot with n firms. Quantity of Cournot n. Okay? Actually, let's just call it QMC, that's good. Okay, so let's call the solution in terms of the aggregate quantity QNC. Actually, let's call QNC, let's fix a notation here. Let's call QNC the quantity of one firm in polynomial firms, okay? Quantity.
Or you can just put like QC, but it's I, comma, N. It's from I out of N firms.
We could, but that has more layers. But I'm just trying to find like some good way to think of this. Quantity of one firm. Okay? I'm just trying to organize myself because I know I can get a bit disorganized sometimes, and I'm trying to be like as clean as possible. Okay? So let's call QNC the quantity of one firm when there's n firms competing. Okay, and the overall quantity is equal to n times QNC. Okay, this is market Q n firms. Okay, and what are gonna be, okay, so that's good, that's the solution of the second stage. And what about the first stage? In the first stage, the profits of within firms, if I expect there to be n other firms in the market, right now I have to fix expectations about how many other firms are going to enter. Right? If I expect there to be n other firms in the market, the profits of this firm are going to be the inverse of the function at n times QNC times QNC minus C times QNC minus the fixed cost of entry, which I'm gonna call, I could call it E or F, but I'm gonna call it F so I don't confuse it with the number E. Okay, F is the fixed cost of entry. now firms are going to enter. I can use this one. Firms are going to enter until the cost, until the profits. If you enter, you can negative, right? You're like, okay, if I expect another firms to have entered, I'm not gonna enter if I of n+1 is less than 0, right? Now we're gonna use a bit of a trick here. We're gonna continuify the end, okay? This just to get rid of like this integer problem, which is the fact that like n is an integer, the number of firms. That's very annoying. So we're gonna think of n as continuous. This is gonna help us with the same intuition without any cost in terms of intuition, and it's much easier to think about because we don't have to think about like, okay, this discrete kind of mathematics, right? So we're just gonna say, okay, the condition for n with free entry implies that phi of n has to be equal to 0. Phi of n free entry, right? We know is n of e. N of e. N free entry equal to 0. Firms are gonna enter until the profits become 0. And that means that E of n times q n uno times q n uno and minus c times q n uno equals the fixed cost of entry. Okay, the profits that you will make in uno within firms have to equal the cost of entry for n to be like the free entry equivalent number of firms. Okay, and free entry and free entry and free entry and here. Okay, so that's it. Basically, then we have to like impose a demand function and the cost. Well, the cost here is like constant, we're assuming, and that's the condition. That's it. You solve this equation, and it gives you n with free entry.
Equals f?
F, yeah, the fixed cost of entry. The profits have to equal the cost of entry. Okay, that's good. But now, what if, here's an interesting thought exercise that people do sometimes, which is, this is called a constrained Pareto optimum. Have you guys heard of the concept of a constrained Pareto optimum? No. You heard of the concept of Pareto optimum?
Yeah.
Okay, so Pareto optimum would be price over marginal cost. But that's not what we want here. Now we want to think about what's the optimal number of firms in the market. With constant marginal cost, if we're thinking of Pareto optimum, it really doesn't matter what's right. If we thought about Pareto optimum, because the marginal cost is constant, if I can do a Pareto optimum, I can have like one firm produce up to price equal marginal cost, that's it. Or I could have 1 million firms, and together they produce up to price equal marginal cost. It doesn't matter, right? They're all Pareto optimal. So the optimal number of firms could be anything, right? It's not well defined. But what if the question were the optimal number of firms in the first stage that I would choose. Now let's say the social planner cannot choose the quantities, they cannot micromanage the firms, but it could somehow decide, let's say, the number of firms in the first stage. But then in the second stage, they play the oligopoly game. They compete in the market and that's okay, right? So the planner now can decide how many firms there are going to be, but it cannot micromanage the firms in the second stage. That's called the constraint Pareto optimum. Okay? So, optimum number of firms. That's the free entry number of firms. Now we're going to talk about the optimum, right? And this we're going to call it the constraint Pareto optimum. You see the difference between the normal Pareto optimum, the unconstrained, and the constrained Pareto optimum? Here I can only change like a hyperparameter kind of the model. I cannot change the quantities, the allocations directly. I cannot say like, okay, these firms are going to produce 3,200 and some of it's going to go to you and some of it's going to go to you and so on. No, they're going to be in the market, but I can change a little bit like the policy, right, which affects the number of firms, and I'm going to try to do that optimally to maximize total welfare, right? But without directly micromanaging and setting the allocations directly, right? Like a kind of like super micromanaging social plan. More like in the real world, right? So you're not doing like central planning of every little thing in the economy, but you may be doing like policies as a social planner, trying to affect the equilibrium and try to get the best possible outcome. Maybe you shouldn't even do it, but this is taking a step back from like full central planning, which I never advocated anyway, for the record. Just, I mean, when I don't want to sound like I'm a communist, I'm like, okay, yeah, this is really the best, you know, like full central planning of everything. I decide like how much butter goes to you and who gets the hydraulic butter. You know, whoever, I don't know, went to Kamchatka because they need to be incentivized to go there because they deserve it, because they went to like the worst part, the coldest place in the Soviet Union. I don't know. You see, I'm not saying that. Okay. This is more European Union than Soviet Union, and maybe it's and then maybe it's like you shouldn't even do it. But let's say we wanted to do this, okay? Because then you could know I'm not gonna be like, okay, I don't like the free entry outcome. Maybe I like it, maybe I don't. Let's see what would happen if I could do it in the best possible way. In the end, you can't even do it because you don't know what the parameters to do it well. But would it be maybe a good idea to do this? And if we did this, would we want to have more or less firms than this one?
You have less firms.
We want to have less firms. Okay. That's it. Maybe. Why would we want to have less firms?
Because more firms would mean negative profit, and no one's gonna operate under negative profit. The market's gonna disappear.
Okay. More firms than this would be negative profit, and that's that. But what if you could compensate the firms?
China does it.
I mean, if this increased total welfare with more firms, you say, look, there's not enough firms, I could compensate the firms
And you can
kind of like subsidize them, so we have even more firms and more competition, and it's good for consumers.
But it's not a market mechanism, right?
I mean, that's not a market mechanism, but neither is having less firms, which is what you said. The market mechanism is this.
But if you have more firms, it would be like better in terms of welfare for the consumers, but not for the firms, right?
Depends. Because if the cost that you have to pay for having more firms is super high,
But the more firms I have, the better it is for the consumers, right? But there's a cost of having more firms. From a social point of view, Well, there's a cost of having more firms, which is that the profits are going to be lower, maybe even negative.
Mhm.
Governments may need to subsidize them, which is
You
negative.
really
Or
have to
we-
subsidize them.
So we're
So you have to tax the
including,
consumers to do something. Else.
so we're including the government as an agent.
Sorry,
We're including the government as an agent, like,
I mean we're thinking of this as the government choosing the number of firms. I mean it's a very abstract exercise. The government wouldn't directly say, well, maybe in some cases yes, like in Spectrum, you could think the government decides how many firms are going to be there. That's not free entry. So
But always, if you increase the number of films, the profits are lower.
if there's more firms,
Yeah, but maybe it's even better, like maybe they even increase demand, like because they compete and they become better both and they, I mean like why has that always to be the case?
would they increase demand? I mean here the demand function, at least in this logic,
It's not.
is P of Q. It's exogenous. It's like we take as given what's the inverse demand function.
but if the
And it could be that if they lower prices, there's more quantity demanded.
Yeah.
But if the government subsidizes the number of firms, then it's an illusionary increase in welfare for the consumers, right? Because the money has to come from somewhere. So it's a no change in total welfare because it has to come from taxes. Like you're subsidizing yourself.
I mean, it might be. I don't know. Is it clear from this discussion what's the optimal number of firms?
Yeah.
It's clear for him. It's not clear for me.
For me,
I
neither.
think you have to have less amount first.
I think we have to do the math. I mean,
Yeah.
You want positive profits so firms can reinvest in themselves, right? Because the problem with perfect competition is that they don't allow for
Right, right, right.
innovation.
reinvest in themselves. Now we're going to like a model with investment. That's like chapter 17 or something. Let's stick with chapter 4. but let's do it to see like what the math of chapter 4 says. Okay, so what would be the optimal number of firms and how do we even think about it? We have to do welfare as a function of the number of firms. Right? That's the fact. And welfare is the sum of consumer surplus and producer surplus, right, which is profits. So welfare within firms is going to be what? It's going to be consumer surplus, which is the interval between 0 and n times QNC of what? Of the area between the inverse demand curve and the price the price set by the market with this number of firms, right? So it's going to be the interval of the inverse demand curve, which is like P of S minus P of N times Q and C. Yes, right? This is consumer surplus. Plus producer surplus, which is going to be the sum of the profits for all the firms, right? So it's going to be it's going to be revenue, it's going to be the price of N times Q and C times N times Q and C minus marginal cost times N times Q and C minus the number of firms times the fixed cost per firm, right? I mean, if the government wants to put like firms, it still has to pay the fixed cost for each firm. All right. So now we need to take derivative of this with respect to N. Well, first we could, I guess, do this interval here, right? Because this one is easy. This is just a constant, So the integral of this is going to be the area between of a rectangle, right? That has a base equal to n times q and c, and height p of n times q and c. Okay, so we can do that integral. So this is going to be equal to the integral between 0 and n times q and s of p of s ds minus Pn, Q and C times n times Q and C. These cancel out, right? Because plus Pn, Q and C times n times Q and C. So those cancel out, minus C times n times Q and C minus n times F. So now I need to take the derivative, first the condition of this with respect to n. Okay, so what's the first condition of this with respect to n? Okay, before we do it, let's realize something. Okay, we messed up a little bit in the notation. I don't think we messed up, but we made the notation a little bit tricky for the reader, right? Because it's like, we call this UN C, right? The quantity, the Cournot with n terms. We call it Q and C. Is that a function of n?
No.
Yes.
Oh,
It is, but it kind of looks like it's not, right? Because we didn't write like QC of n
yeah.
in parentheses, right? But yes, Q and C depends on n.
Oh yeah, because it's the number of ferns. It's different to Q, I see.
So that's why I was trying to think of the right notation here, and I understand. But we should have called it QC of n, right? This would have been better. Right, so let's call this QC of n. Just to, it doesn't matter. I mean, the important thing is we know that it's a function of n, right? But you know that we're taking derivative of this stuff of n, right? It's a function of n. Okay, so this is a function of n, and this is a function of n. This is a function, and this is a function of n. And this is a function of n. And this is of n. And this is of n. Okay, so it's Q or no as a function of n.
I'm honestly having trouble with the integral.
Yeah.
Because the limit of the integral includes n. So how does that work? Also because like PS, DS, it has nothing to do with n. I mean, is it a dumb question? I mean, I stand by it.
Is it a dumb question?
No, I agree with her.
We're having trouble with the integral
Yeah.
because the limit of the integral includes n.
But we can just like operate the integral, right? We can evaluate it at the upper limit, less evaluate it at the zero limit. Then what, and the good miracles about zero is that it takes away
What is
everything.
PS?
We can't evaluate this integral.
Okay.
So we don't
But it's
catch
not
it.
about a question. It's a question. Okay, it's not about a question, and you guys know the answer to this question.
Okay.
You guys know it, and I'm gonna give you a hint. This is a question that Leibniz pondered in the year 1700. Oh, 1689. I mean, I don't know exactly. Okay? So given that hint, you're asking the same question that Newton and Leibniz asked
So I was not gonna get it.
when they were inventing differential and integral calculus. So is it a bad question? I mean,
An ancient
in the year
question.
2026, it's kind of a bad question.
Okay.
But overall, it's a great question.
From now on, I'm gonna be an introvert.
So what do we need to use here? Something fundamental.
It's just, I don't know, I'm just gonna like say. Like, we know the rest of the terms, right, because it's minus, so it's minus.
Okay, we know the rest of the terms.
Yeah, yeah.
So
Yeah.
okay, let's do this first. So let's do this first. So this is what?
So that,
Here we have to apply like the multiplication and the chain rule.
Yeah, so it's C times Q and C.
C times
Q and C.
C times n. C times the derivative of m, so C times Qn. Q C of n
Yeah.
minus
Minus
C.
C times n times Q prime.
times the derivative of Q of the known quantity with respect to number of firms. Okay, good.
Minus F.
Minus f. Plus the derivative of this interval with respect to n.
Which is PS? No, is PS times QS of n plus NPS Q prime,
Which is what?
because the result is n times QC of n times PS, right? Because it's that minus C.
Now is what, sorry?
N times QC of n times PS, because the other part is 0. Is the top minus the bottom.
This interval
Yeah.
is. I mean, okay, what is this interval?
so it's
It's-
in the area, yeah, sorry.
Okay, if we wanted to evaluate this interval, which we can't do in closed form, what would we do?
We will multiply PS times the top and subtract PS times 0.
No, that's if PS were a constant.
Ah, okay.
But PS is not a constant, so in order to do the integral of the function, if the function is not a constant, we have to find the antiderivative, right?
Mm.
So suppose we found the antiderivative of P of S, and we called it something, right? Let's call it Q.
Gamma.
No, not Q.
Gamma.
Gamma,
Por ejemplo.
right? So
That is the most complicated symbol ever, okay, gamma.
yeah, so we're getting okay. Let's call it like capital gamma to scare people. Boom. Okay, so let's say that gamma is the antiderivative, right? So gamma prime of S is equal to P of S, right? Of Q. Okay. So we know a function that is like that. So then the integral, now this is equal to the integral. No, sorry, it's equal to gamma of n times qs of n minus gamma
Times it.
of of 0, right? Minus c and so on, right? So we found the antiderivative of p of s, right? We call it gamma. And we know that, okay? And so we can rewrite that as gamma evaluated at this minus gamma of 0, right? Minus c times n times q of n. Okay, so now the derivative of this is what? Okay, we already did the derivative of this part.
Yeah.
Derivative of gamma 0 is 0.
Is
This is
zero,
just a
yeah.
constant. Derivative of gamma of n times q of s of n
P depending on the same.
is p,
Depending on the
right? Is p times the derivative of n times
Vale.
q s of n, right? So this is going to be p evaluated at p times q s of n times the derivative of n times q s of n with respect to n, which is going to be q s of n plus n times derivative of q s of n divided by n with respect to n. Okay? Okay, the fact that the derivative of an integral with respect to its, like the, what do you call it? The upper limit is equal to the function itself is called the
So the same function evaluated at the upper limit, it has a name.
no. Yeah, this has a name, this result.
Is it named on there?
It could be called Leibniz theorem or Newton's theorem, but it's not called that. It's called the fundamental theorem of calculus. Remember this fundamental theorem of calculus? Yes, you do. You studied this in math 1, right? But in math 1, you were young, and you were in this math class, and you were like, why do I need to learn fundamental theorem of calculus? You know, I'm too cool for this. And what's the use of this anyway? Like, who cares about fundamental theorem of calculus? They call it fundamental. Doesn't seem very fundamental in my life right now, right? And it has a beautiful kind of geometric interpretation, right? Because it's like basically if you have like some function, right? And we have the integral of this function, right? Now the integral, the area under the function, the change in the area, if you change the upper limit by 1 unit, is going to be approximately the height of the function at the upper limit. You see what I mean? Because it's going to be like a rectangle of area 1 or area dx, or base dx, times the height of the bar, which is, and the height of the bar is going to be the function evaluated at the upper limit. You see what I mean? The change in the area of the integral with respect to the upper limit is a function, the marginal change and the infinitesimal change. If you add like 1 or you add like delta x dx, and then you do like the change, the rate of change relative to dx is going to be that upper limit. You see what I mean? Because it's like you can like add a little bit of area, but here, where this is the height. You see what I mean? If this is dx, then this rectangle is going to be the upper limit of f of x evaluated at this upper limit. times dx, right? So the rate of change is going to be this divided by dx. It's going to be like the height of the perimeter. If dx is equal to 1, think like an economist here, just check the increase of 1 unit, then approximately the area is 1 times the height. Okay, and this is called the fundamental theorem of calculus.
You sing. Okay, so no me acordaba, pero sí.
Okay, so now we have this, we have 10 minutes, let's see if we can compare. Okay, so now the optimal is going to be when this is equal to 0. Okay, so can we interpret this? Can we interpret this condition?
Because what does it mean that C is multiplied by M and then multiplied by like the change in QC given a change of M?
This one?
Yeah, like, yeah, what does that mean?
Doesn't mean anything for now.
For now,
Let's see if we can give an interpretation. We can actually. Okay, so let's rearrange the terms. So I'm gonna put first the terms that don't have this delta Q. I'm gonna separate the terms that have this derivative of QC with respect to n and the terms that don't. Okay? So first let's put all the terms that don't have this derivative. Oh, maybe first let's put the terms that have this derivative, because I want to try to take like common factor, this derivative, and see what it is, okay? So terms that have this derivative are this minus Cn, that's the derivative, and that one there that has like P times N, times the derivative. So it's going to be P of N times Q of N, you know, times N and minus, well, and they all have N, so I'm going to take them into account. Minus C times N times the derivative of Q to know of N with respect to N. Okay? And then the other terms are P of N times Q1 or no. I don't know why I wrote QS. I should have wrote QC, sorry. I was running too fast. Times Q of N minus C times Q of N minus N.
You mean like when you put S up there, it should be C?
Yeah, that should be C. I don't know. I mean, I was probably just writing C fast and that should be zero. Okay. Okay, so now pattern recognition. price times quantity minus cost times quantity minus fixed cost is equal to,
This is the profit, right?
this is the profits of one firm, one source. Understand? Okay? And the profits, if I evaluate them at the free entry, so in particular, if I evaluate this, evaluate it at the entry, this is going to be equal to
0 it's supposed to be.
0, right? So then we only have like one term, right? And this term, what sign does it have? This is
Dollar margin?
the dollar margin. Remember, these profits are net of the fixed costs. So the dollar margin, for that to happen, has to be positive, right? If the dollar margin is negative, I'm not making positive profits, right? With free, because I have to pay at least the fixed cost. So I have to be recouping that with a positive dollar margin. Number of firms, positive. And the change in the quantity with respect to the number of firms, change in the quantity of one firm. If I have more firms, in Gounod, the firms as a whole are only producing,
Is it negative because the more firms there are, the less they produce?
the more firms there are, each firm produces less in Gounod, right? I mean, we have the expression, you know, for the quantity within the demands.
So basically, the more firms, the less welfare, because the relative is negative.
The more firms, the less welfare. Evaluated at
The free entry.
So this is negative. At least in the case of linear demands, so this is true. There's a case where this is ambiguous.
Mm.
And I don't know. Okay. In linear demands, this is clear. Okay. So if this is negative, then that means that if I'm at the free entry number of firms,
Once you reach that equilibrium, you're not interested in getting any more firms.
then I don't want.
To add
Then
any
if
more
I
firms.
add more firms, it reduces my welfare.
Exactly.
And if I reduce firms at the margin,
You increase
it increases.
the welfare, yeah.
It increases my welfare, right? So the optimal number of firms, the one that solves that, has to be less than the free entry number of firms.
Can you repeat that again?
Ah, see, there were less firms.
There are fewer, yeah.
Not-
So there's fewer firms in the socially optimal, constrained by the optimal problem than in the free entry problem, okay? And why would this be? I mean, there's a trade-off, right? It's not obvious, like what will happen, because on one hand, having more firms benefits consumers. And actually, there's some models in Gounod, this is true. It's not true always. If you have differentiated products, it's not true always. It's ambiguous. Okay, if the new firms are introducing new products, then maybe it's better to have more firms. Here, in this case with homogeneous products and Gounod and other firms are the same, and they also have the same marginal cost, free entry produces too many firms compared to the constraint by the optimal. Okay? And The negative part is that basically, let's look at this first order condition again, basically. Well, no, let's not look at it from the first condition. Intuitively, what's happening here is you have to pay the fixed cost many times to basically replicate the firm that's basically identical to the firms you had. And the firms, when they're thinking about entering, they're like, okay, I have to pay. But from the point of view of the social planners, they already have firms doing the same thing. And when you go into those firms, new firms, they benefit consumers, but they're taking profits, which you do care about, from the other firms in the market. And that effect in now is very large. Okay? That's called the business stealing. Okay, there's an excess entry. And the main reason is there's an externality here that the firms don't internalize, is that when they enter, most of their profits that they're making are coming at the expense of the other firms that are already in the market. Okay, but the social planner does internalize that, because the social planner here takes into account the producer surplus of all the firms. Okay, and the consumer surplus.
How did you end up to that conclusion?
With this conclusion,
Yeah.
basically, well, actually I didn't fully prove this conclusion. You're right. Well, because I didn't prove that this is negative everywhere. I proved that this is negative at this point, because that's easy. But at least what I would have to prove is that this never becomes negative again. Right? But the logic here was this, this is 0, right? At the point, at the free entry, let me look at the diagram. Right, so if this is like W prime of the number of firms, and this is the number of firms, at the free entry point, this is W prime, and somewhere, okay, let's just assume that this, let's see if it's going to be true, but like the marginal welfare of a new firm, finding a new firm to the market, is decreasing. Okay, so this is downward sloping. Now the question is here, the optimal one, when start. Okay, so if we think, okay, adding the first firm is what's going to be the most payoff from the social welfare point of view, and then like each firm that I add is going to add less and maybe even negative. Okay, so is this n star to the right or to the left of the n fixed entry? And it's going to be to the left. Okay, so n fixed entry is going to be profits as a function of n, right? And this is the zero profit condition, right? So the free entry one is going to be with the zero profit condition crosses the x-axis. Okay, but with the profits as a function of n cross the x-axis. And this one is going to be where the marginal welfare as a function of n crosses the x-axis. Another question, the idea here is to say, okay, let's take this point. At this point, what's the value of this derivative? W prime of n. Right? And basically we can evaluate the derivative like fairly easily at this point, because this part, the part of the derivative is the profits. Right? And so the profits part is going to be 0 at n free entry. You see what I mean? At this point, this part of the W prime function, the W prime delta W of the n, is 0. Okay? And then and the other part It's negative.
It's not.
Because this part is positive, the profit margin is positive, M is positive, and then the change in the quantity of one firm, with respect to number of firms, is negative. Okay, so the W prime of M is negative, evaluated at this point. Okay? And that's kind of like, then it has to look like in this diagram. It could either be like above, the W prime is like here, but it has to be under it, and that means that M star, the part where the W prime is 0, has to be to the left. I mean, if the W prime were really weird, and it's something like this, or here, I don't know, like a lot of things could happen, right? If the W prime were like this, I wouldn't put it wrong. It's not like that, I promise. Well, you would have to make assumptions, like linear demand, for example, is not like that. I guess you could make some assumptions on the demand function where this doesn't hold and it's not true. The linear demands, this will hold, and then it will hold a little bit more generally. What I guess I haven't done is provide like the minimal set of assumptions such that everything's well behaved and this intuition still holds, then these results still hold. But we're not here to provide the minimal set of assumptions for this. I mean, if you want to do it, go to ChatGPT, write down this problem and tell it to, or to Claude, and find a minimal set of assumptions such as this is true. I don't know if there's a paper, if the original paper that publishes Kuno 300 ASAP, they might, but maybe find a even lower set of assumptions and you can publish a paper in perfect letters. No, people don't really care too much, but it's a valid paper to write. And here we look like we don't care so much about like going into that level of trying to realize the theory. We're all right. Anyway, you see what I mean? It's like what I'm writing here is like the version of a theorem that like works and is nicely behaved. And maybe I left some assumptions out, okay? I wasn't super careful. It's like I give you the main result. It's possible that you can write some kind of examples, okay? Don't kill me. Try to do it. I mean, don't try to do it because it's a waste of time. Okay? I mean, you have better things to do with the time than that. I think, I don't know, some theories, Marcus would disagree. He would think like, oh, that was like a fun paper to write. I don't. Okay? Like, don't do this for your TFM. Do something that's like taking the insights from these theories and going to the data and trying to test this. I don't know. You can find weird assumptions that are never going to happen in practice, such as this is not true. Now there's other assumptions. You see what I mean? It's like, don't come to me with like some really like convex demand curve where like this is not true. That's I don't really care about. Like demand is never going to be like high complexity of a measure. A different thing is if you told me something that has insight. Okay, so something like, okay, but what if the products were differentiated, right? Something more meaningful. Then this might hold for actual economic reasons that people might care about. You see what I mean? That's where the theory really becomes interesting. The other stuff, maybe you have to do it because, first of all, it's like, okay, I want the theory to be really tight and get it done, and just the quality of the theory paper does depend a little bit on that. I mean, if you really went all the way to find the minimal assumptions. For this to hold, and some technical assumptions, you know, where this might not hold, but that are not really meaningful. Or maybe they have some meaningful economic interpretation, and that's nice, but they're not so meaningful in the real world. You see what I mean? But then the theory becomes interesting when you start questioning like major assumptions like homogeneous products and things like that. I mean, like this may not hold if you relax homogeneous products. So then you write a paper with differentiated products in this, which people have done. That's like Dixit Stiglitz, 1977. Okay, you see where I'm going here? It's like, I don't want to dismiss, like, trying to generalize this, or like, first of all, I wrote in a very general way, so I'm in the wrong here. I'm in the wrong here because I didn't really make the assumptions, and I kind of make the assumptions on the go to be like, okay, yeah, this is gonna be negative. I was a little bit careful. Okay? In order to make progress and get intuition. And second, all of what I said is gonna work in the linear case. You can show it. I can show it. And you guys can show it too. Yeah, but because I wrote it in a more general way, it also holds in cases that maybe are closer to the linear case, or maybe if you get very far away from the linear case, suddenly this is not true, or it's not always true and you have to be more careful. You see what I mean? And I'm not trying to go there. Okay, you could, I mean, you could do it. It's not wrong to do it. It's just not something I did this once. I mean, and I published it in Connecticut. Not only because my co-author was US, and I don't know, but also the paper's really good. People love it. I have basically one theory, like real theory, hardcore paper. So I did this kind of stuff, trying to find the minimal assumptions to whether the equilibrium exists and is unique, and all that stuff, and all the results hold. It can be done, it should be done for people who theory, for the ones who are their type. For everything to be type, you have to so do it or don't do it.
Jose, how many years of mental life did be trying to do the non-linear thing cost you? Yeah.
How many years of my life?
Yeah, of mental life, because that must be super heavy, super complicated.
I don't know what this one is. I don't know. I mean, now with AI, it's pretty much easier. You come up with the ideas, you go through it, and you have to check and understand. I'm not a theorist. I have one theory paper, it's really good. And then that's it.
Yeah.
¿Te puedo tomar el toque una foto de la portada y